In this question, we discuss here there are two charges, suppose say Q1 and Q2 at a separation distance of r. Then if medium is air, then force between the charges in air written as 1 upon 4 pi epsilon naught. Here epsilon naught is the permittivity of the vacuum and product of the charges, and here if say in between the two charges at the same separation distance, if medium, dielectric medium placed in between them, then the force in medium will be given by 1 upon 4 pi epsilon naught K, where K is called dielectric constant. The dielectric constant of the medium, and charges divided by this. Suppose you will divide equation 2 by 1, then here everything cancel out except K. Force in medium upon force in air, ratio is 1 by K. So force in medium is reduced by a factor of K. Option 3 is correct. In this question, two pi2 charges Q are separated like this at a distance of d, then force repulsive will be given by 1 upon 4 pi epsilon naught Q square divided by d square. Q can be written as 4 pi epsilon naught f d square, and because of square, now Q can be written as NE 4 pi epsilon naught f d square, like this. So N will be 4 pi epsilon naught f d square upon E. So it can be written in the root of, so 4 pi epsilon naught f d square divided by now d square, option C. So N is the number of missing electrons. In this question, in first figure, draw the first figure like this. Q is the charge, separation distance is r, and this vertical distance perpendicularly y. In second figure here, it is clamped here. So this distance perpendicular is y by 2, and this distance is r dash. In that first case, is a T1, the tension, theta 1 is the angle, tension here is T2, and now you can resolve T2 cos theta 2, एक्शन हो जाएगा T2 sin थीटा. यहाँ पर फोर्स है F डैश mg, फोर्स एक्टिंग इन द डाउनवर्ड डायरेक्शन, को भी रिजॉल्व करेंगे. तो अल्टरनेट एंगल थीटा 1 T1 cos theta 1, and here T2 1 cos sin theta 1 mg acting in the downward direction, and this is F. So now in equilibrium condition, horizontal and vertical forces को equate कर देते हैं. 1 sin theta 1 equal to F. F means 1 upon 4 pi epsilon naught 2 square upon r square, and T1 cos theta 1 equal to mg. Divide here tan theta 1 given as 1 upon 4 pi epsilon naught 2 square upon mg r square. Putting the value of tan theta 1, r by 2y equal to 1 upon 4 pi epsilon naught 2 square upon mg r square. So r cube can be written divided by 2 1 upon 4 pi epsilon naught 2 square y upon mg, equation 1. Similarly, in figure 2, T2 sin theta 2 equal to f dash means 1 upon 4 pi epsilon naught 2 square upon r dash square, and T2 cos theta 2 equal to mg divided by this division tan theta 2 equal to 1 upon 4 pi epsilon naught 2 square upon mg r dash square. Tan theta 2 means r dash by 2 is also 1 by pi by 2. This equal to 1 upon 4 pi epsilon naught 2 square upon mg r dash. So r dash cube 1 upon 4 pi epsilon naught 2 square y upon mg. वन इक्वेशन 2 में राइट हैंड साइड इक्वल है तो लेफ्ट साइड भी इक्वल होगा. लेफ्ट हैंड साइड इक्वल करके फ्रॉम इक्वेशन 1 एंड 2 we get r dash cube equal to r cube by 2 or r dash on r whole cube be 1 by 2 or r dash upon r will be 1 by 2 to the power 1 by 3. So r dash is equal to r upon 2 to the power 1 by 3. So here r dash के लिए आ गई. Option 4 is in this question. This both are having charge q, so repulsive force is there between the two charges. If charge is leaking, if q charge is decreasing, so force is decreasing, these two charges will come closer with velocity v at that instant when the gap between them is x. So here d is very very small than L, theta is small, so theta is tan theta is equal to sin theta. So now in equilibrium condition, T sin theta is equal to F force F and T cos theta equal to mg. Divide them, tan theta equal to F upon mg, and theta is small, so it is approximately sin theta F upon mg. And what is sin theta? Sin theta is x by 2 upon L by 2 upon L. here F. F means 1 upon 4 pi epsilon naught q square upon x. It can be written as say q square equal to 4 pi epsilon naught x cube mg on 12 constant. So q square is directly proportional to x cube and q is directly proportional to f to the by 2. Differentiating with respect to time t, dq by dt equal to t by 2 x to the power half, and by chain rule x by dt, that is velocity. In this question, this rate of leaking charge, that is constant. So ये डिफरेंशिएशन हो जाएगा 0, t by 2 उधर जाके 0, x to the power half, and this is the velocity, or velocity is inversely proportional to x1 upon x to the power half or x to the power minus half. So this is option 1 is correct. Question: charge on proton and electron is slightly different. So charge on proton apply delta E on electron this. So this is the difference of charge. This is the charge on hydrogen atom. So this is the charge on hydrogen atom. This is the charge on hydrogen atom. There are two atoms at a gap of d. Now we have to find a force and net force. Electrostatic and gravitational, they are also equal. So here electrical force equal to gravitational force. Electrical force is 1 upon 4 pi epsilon naught delta E square upon A square, and G, gravitational force G, M1, M2, M of hydrogen atom upon D square. So this cancel out. Now delta E whole square is what? G M square upon 1 upon 4 pi epsilon naught and profit. So you can write here delta E equal to M square upon 1 upon 4 pi epsilon naught, or G, just by putting the value 6.67 10 to the minus 11 upon 9 into 10 to the 9 M. बाहर आ गया M दिया 1.67 10 to the minus 27. तो हम सॉल्व करते हैं, रफली 10 to the minus 37 कम गैप है. So option here is in this question, charges A and B, charge plus Q minus Q, and the force between them, that R is the distance. So force is given as K Q square upon R square, that is F, given in the question. If 25% of charge Q transferred from A to B, means here rest is 75% charge remaining, or 3 by Q of Q charge positive on A and on B, what is the charge here? Minus Q and plus 1 by 4 of Q, that is the 25% charge is transferred, that comes here minus by 4Q. At the same distance, the new force will be K upon R square, 3 by 4 of Q and 3 by 4 of, so it can be written here 9 by 16 A Q square upon R square. From equation 1, it can be written as F. So F dash will be 9 by 16 of F, means option C. In this question, charges for Q at x equal to 0 in plus 4Q charge at x equal to A, that is minus Q charge x equal to A at this position plus 4Q charge. So here all the charges are in equilibrium but not stable. Because if you disturb a little bit, suppose this, then attraction more than the repulsion. Suppose this Q charge, central charge in equilibrium, so disturb a little bit towards say right or left, then the attraction force will be more than the repulsion. So all the charges are in unstable equilibrium. इक्विलिब्रियम तो होगा बट अनस्टेबल. इफ यू डिस्टर्ब cannot, option C is correct. There are two equal charges plus Q at the center. If you put another charge Q, the system will be in equilibrium if Q is equal to, means by logic it should be negative. अगर नेगेटिव नहीं होगा तो क्या होगा, ये सेंट्रल चार्ज तो इक्विलिब्रियम में है बट एक्सट्रीम चार्ज कैन नॉट बी इन इक्विलिब्रियम. मतलब अगर पॉजिटिव होता है सेंटर वाला तो क्यू को इस क्यू से रिपल्सन, इस सेंटर वाले से रिपल्सन, तो ये इक्विलिब्रियम में कहाँ रहेगा, मूव कर जाएगा टुवर्ड्स राइट, सिमिलरली टुवर्ड्स लेफ्ट. इट इज वेरी नेसेसरी एट सेंटर it should be negatively charged must be. Now say to find the, suppose r is the distance between them, this will be r by 2, r by 2. If we are interested to find out the magnitude of this q, it means here either extreme position left or right, इसी पर भी हम नेट फोर्स जीरो कर सकते. इस क्यू की वजह से इधर रिपल्सन होगा, माइनस क्यू की वजह से अट्रैक्शन होगा. तो अगर F1 F2 को हम इक्वल कर देंगे तो हमको मैग्नीट्यूड F1 मीन्स 1/4 पे एप्सिलॉन नॉट और K Q into Q upon R square. F2 attraction 1/4 पे एप्सिलॉन नॉट Q and Q upon R by 2 का square. So 1/4 pi epsilon naught Q cancel out, R square also cancel out, means Q should be, तो वैसे लिख सकते हैं हम लोग, Q should be equal to by 4, but by logic it should be Q. Option 1 is correct.